All right, this is part 2 of the 7.1 day 1 notes on simplifying and verifying identities. There was one last simplifying problem that I wanted to show you guys because it has a little bit of a different approach to it. So we're going to walk through that one with you, then move into the verifying, which is a little bit different approach. But again, when I look at any identity problem and I'm trying to decide how to get going, it's like, what part of the identity sheet does this drive me to? There should be some things in here that just kind of quickly push me to some spot in the identity sheet. And when I see those squares, right away my first thought is head to the Pythagorean identity part. There's also our basic ones that they kind of are useful almost all the time somehow, but where do I start? What's my substitution? The thing about starting here is that I may not necessarily always start any given identity by just doing substitution. I might do some other kind of manipulation, which could be algebra, signs, fraction work, all kinds of stuff. So there's a little bit of creativity involved, and that's where you guys might find some of these problems get a little bit harder when you have trouble getting that sort of creative start going. In this one, I could go all sine and cosine and kind of try to mess with this. I think that'll probably make it a little bit worse, actually. Sometimes I just got to think about what my basic math brain would tell me is like, I've got a fraction minus a whole number. Why don't I just get them put together with a common denominator, like I would always do, right? To give yourself a common denominator, you'd have to change this to secant squared over secant squared. So that's what we're going to start with. That 1 becomes common denominator, right? And then, of course, when you have a common denominator, the whole purpose of doing that is so you can combine those fractions into one fraction. So get them all over a single denominator, right? There's your common denominator. And then we're going to have to get, so right now I'm doing fraction work, right? We're going to have to get a little bit creative here because as I look at this stuff, I'm still kind of like, well, great, I got them put together, but I still have all this stuff going on. If you look up in the list here, you'll see this one. Secant squared minus tangent squared. Well, this is actually in reverse, but turns out you can do a little bit of manipulation with that by factoring out a negative. When I factor out the negative, you look at now I've got factor out a negative from these two. Now I've got a negative tangent, positive secant, which is actually what this says. So it turns out this expression in red, these two combined, is really equal to 1. So 2 minus 1 is 1. 1 over secant squared, cosine squared. Now again, as you look at it, the steps of it, you go, well, that didn't seem that bad. Of course, that's because I'm talking you through it, right? So would it occur to you to do all this stuff? And that's where you guys will get into some of the identity problems in the homework, where some will be quick and easy, take you like 10 seconds, maybe 30 seconds. Others you might sit and stare at it for a little bit, and I suggest you go on and come back, and hopefully something hits you, or you shoot me a message through WebAssign and ask a question about it. Okay, we're going to switch over to verifying. So verifying is actually a little bit different. Verifying is an equation. So what you're really trying to do now is prove that this side is equal to this side. And I'll tell you things we don't do right up front is you don't work on both sides of the equation. You try to turn one into the other. So we generally start with the more complicated side. Sometimes that isn't always obvious, but try to pick one that looks more complicated and then move to the simpler side. Sine and cosine is a good fallback thing if you're getting frustrated or getting stuck. But remember, don't always do that. Sometimes that isn't helpful. Sometimes that makes it worse. But verifying is showing one side is equal to the other. So here we go. Again, start with kind of a simple one. So since I've got a pretty simple one, I'm going to use the basic identities. Right away, the first thing I'm going to do is get all this changed into sine and cosine. The goal here is to turn black into red. So this being like slightly more complicated, get that to be that. That's what I want to show. So what I'm doing here is now as we go through some of these, I'm going to start sort of jumping over a few steps and trying to have you guys sort of see like, okay, I can do this without writing everything out. Like 1 over cosine is my secant. Then I have 1 over tangent, which is a cotangent, and I made that cosine over sine, and I did not show that work from black to blue, right? So I did a couple things, like right away 1 over cosine, and I broke it apart. I had a 1 over tangent, which now becomes cotangent, which becomes that. Cosines would cancel, 1 over sine, and then I verified the identity. So again, from black to blue there, I left out a little bit, but I'm trying to get you guys already just by watching the video to start to be able to see some of that stuff and do it without having to write down. There's already enough steps to write in a lot of these problems. So if you can cut out a little bit, but the logical thought process is all there, then you're good. All right, so that's verify. Show that one side equals the other side. So for this one, again, this one, I think sometimes you have to look at problems like the left side of the black and say, well, do I just have initial reaction? It isn't always identity. My initial reaction is I'm subtracting fractions. So if I'm subtracting fractions, I guess I need a common denominator. And the common denominator would be cosecant squared of x minus 1. This is like an a plus b times an a minus b, a squared minus b squared, right? Sum and difference idea. And then to create that common denominator, I need to multiply each fraction by the other denominator. So I'm multiplying here by cosecant of x minus 1. Here, top and bottom by cosecant of x plus 1. That's the work I have here. And then clean up that numerator and denominator. So again, I'm doing a couple things. I'm cleaning this mess up, but I'm also trading that out with a Pythagorean identity up here. So cosecant squared of x minus 1 being cotangent. And then getting rid of my fraction by doing the reciprocal idea. Actually, I'm there. There we go. Okay. So 1 over a cotangent, or cotangent squared, is a tangent squared. And check, I got it. So again, one side to the other. Show. Prove it out. That's verified. A couple more will be done. So I see some Pythagorean stuff, so I'm looking for what I can do with that. 1 plus tangent squared right away. I see that up here at the top as a secant squared, so to me that would be a logical thing to do. What I'm going to do next, again, there's this little things I'm going to show you guys along the way, is I'm going to manipulate the fractions. Now this is actually undoing a common denominator, and there's a reason for that, because I'm looking, besides just kind of blindly working on this side, I want to look and see, like, where am I headed? Where am I headed? I can already see to myself that 1 over secant squared is cosine, and secant over secant is 1. So I can already see that I'm pretty much there. So this is what I would call as a fraction split. Make it a common denominator. Show the common denominator. And then I'm basically there. So that's my cosine, that's my 1, and of course switch the order and you're there. So again, what I did was, there's an identity piece up front, there's a fraction manipulation part of the problem, then identity and just basic idea there, and then a little bit of switching. So kind of a mixture of stuff going on in that problem. Okay. One last one to wrap it up here before we finish up the notes. So because these are, how do you know, like, when to do the squared stuff, when to not? Of course, if I don't see anything squared, I'm probably most generally not going to try to create a squared situation, Pythagorean identity. So I see a bunch of basic stuff going on. I'm going to go with basic now. Because I'm going with basic, there isn't really much I can do but go all sine and cosine. So here's my starter, my all sine cosine. So cosecant 1 over sine. 1 right away, I'm doing sine over sine because I know I'm going to need a common denominator. Cotangent cosine over sine, and then what I did here to get the cosine to become this, I thought of this as being over 1, and I multiplied it by sine over sine to give it the common denominator of sine. So I've got all common denominators being sine, so now what I'm going to do is clean that mess up, get that combined as my numerator, that combined as my denominator. Then the next step is something that I like you guys to remember that it's okay to do. I'm not going to flip and multiply. I'm just going to cancel those out. That's a shortcut. I could take this denominator, flip it over, multiply by the numerator, then cancel the signs, but now you're doing a bunch of like extra writing and stuff, just wasting time in a problem that's already got plenty going on anyway. So it's legitimate to do that because I could flip and multiply. Now, when I go to the next step, you have to think of it as though you did flip and multiply, right? So if I flip this over and multiplied it by the top and the signs would cancel, here's what I would have. So while you're still doing it, you're just not writing it on paper. That's what it amounts to. And then you look at this and go, okay, this is all fraction work. It's fraction work. There's some canceling. Good. But I'm looking at the end going, how in the heck does this become this? Like, I don't even know if I'm even close to that. Well, again, you got to start seeing some stuff going on. And what I see here is a little bit of a factoring that might help me out if I'm paying attention to my numerator. So what I'm going to do is factor that denominator out, take the cosine out, and then you can see the canceling is going to happen here. Gone, gone. Left with 1 over cosine, and what do you know? I'm at secant. Just that simple, right? So this would be a good example. Actually, a lot of this in this set of notes are good examples of problems where, as you watch me do it, you can probably follow the steps. But would it occur to you sitting there by yourself doing it to do the same steps? And on top of that, you can get through identities in sometimes 2-3 different ways and do it legitimately. So I'm just showing you a possibility. I'm not showing you the only way to do these. Some of them, again, have multiple versions that get you through just fine. So a little bit of it is how you see it. Sometimes there really is kind of only one way that really gets you there in an efficient way. That'll be your goal as you work through this first couple days of problems. And the next set of notes, we'll kind of do some other things with the identities, other versions of the problems. But can you spot how to get started? Can you see how to manipulate? Can you get creative when you need to? And everything's got to be, of course, legitimate math and logical and correct the identities. All right, well, good luck on day 1 of identities, everybody.